everyone. Hello. I hope all of you are doing well. My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft and I'm also an educator at Relevel. So now in this video, we are finally starting with all the scheduling algorithms that are available to us. Okay, so we'll start our discussion with first come first serve algorithm. Moving on to, we'll also understand about shortest job first algorithm, priority scheduling algorithms, and many more algorithms after that. Okay, so let's quickly get started and take our discussion forward to talk about different scheduling algorithms. But before actually moving ahead and talking about all the scheduling algorithms which are available to us, we are going to take a little bit more detail into a few more terminologies which are going to be used again and again. So it's very important to have a good understanding and the correct meaning to know about these terminologies. Okay, so what we'll do is we'll first associate and understand about various times which are related to whenever we execute a process. Okay, so we'll make a diagrammatical view and then we'll understand this. So we have ready state, correct? From the ready state you go to the run state, and from the run state you go to the terminated or the complete state, correct? This is basically your arrival time. Whenever you come into the ready state, that's what your arrival time is. From the ready state to the running state, okay, whatever time it takes for you to go from the ready state to the running state is known as the waiting time, because you're currently waiting to go from the ready state to the run state. At this point of time, when your task completes, that is what we call as the completion time, and the time it takes for you to run a particular process and go from running the process to the completion of the process is known as burst time. Okay, these are all the terminologies, okay, that you need to understand over here for basically having a good idea about how this basically works. Okay, so with that, some more terminologies that you should know is that there is also a terminology known as turnaround time. Okay, turnaround time is nothing but the time your task got completed, which is your completion time, okay, minus the time where you were entering. Okay, this is what your completion time basically is. Okay, that is one way to look at this definition. The other way to look at the definition of turnaround time would be waiting time plus burst time. This is waiting time and this is the burst time. Okay, and we will be using these terminologies very frequently, so it's quite important that you understand their meaning. Okay, so when we talk about arrival time, okay, arrival time is basically the time at which a process enters into the ready queue. Okay, when we talk about burst time, okay, burst time is the total amount of time required by the CPU to execute the whole process. Okay, the time required by the CPU to execute the whole process. Okay, then we have the completion time. It's basically a timestamp or the time at which the process enters into the completion state, okay, or the terminated state. Turnaround time is nothing but the total amount of time spent by the process right from its arrival time to its completion time. Okay, then we have the waiting time, and waiting time is basically the total amount of time for which the processes wait for the CPU to be assigned to them. Okay, so these are basically all the terminologies that you need to know before moving ahead and talking about all the algorithms. Okay, perfect. Now we can move ahead and start our discussion with our first scheduling algorithm, which is first come, first serve scheduling. So this is actually the most easiest and the simplest CPU scheduling algorithm. Okay. In this type of algorithm, the process which requests the CPUs first basically gets the allocation first as well. Okay. And this kind of scheduling is managed by with a FIFO queue. That is a first come, first in, first out kind of a structure. Do you remember how a real queue works, right? Let's say all of you are standing in a queue to buy tickets for your favorite Marvel movie. Now, the person who stands in the queue first will basically reach the counter first and get the movie ticket first, and then the person after that, and then the person after that. So, the person who comes in the queue first will have his or her request taken care of first as well. That is what a FIFO, I would say, queue basically is. Okay, the data element which is added first in the queue will be removed from the queue as well. Okay, and this kind of a scheduling, which is first come, first serve kind of a scheduling. Okay, this kind of a scheduling is very easy to implement using simply a queue data structure, right? Where you are adding elements at the end of the queue and removing elements from the start of the queue. Okay, now understand one thing, that for any algorithm that you study, right, there is a concept of average waiting time. That means on an average, how much a process needs to wait in order to actually get the allocation for the CPU. Okay. Remember, the lower the waiting time, obviously, the lower the waiting time, the better is the scheduling algorithm. Okay, so what we'll do is we'll take a look at a few processes over here and then we'll understand this. Let's say we have the process P1, P2, P3, P4. So this is the process, and along with that we have the corresponding burst time for every process as well, which is 21, 3, 6 and 2. Okay, here what you can assume over here is that in this particular tabular kind of a format, okay, the arrival time for all of them is 0 only. That means all of them arrives in the ready queue at the same point of time. Okay. Now, what happens over here is, right, you have multiple processes in the ready queue. Now, using a CPU scheduling approach, you have to find out which process is basically picked up. Okay. Now, here, what will happen is, since it's a first come, first serve kind of a situation over here, what can happen is we can schedule the processes based on their, I can say, their arrival in the system. So since all of them basically arrived over here at the very same point of time, right, we usually, to represent how it works, we can use a Gantt chart. Okay, now in the Gantt chart, what will happen is we will just execute the process out of sequence and represent it. Okay, so what will happen over here is, first we'll pick the process P1. So starting from the 0th index up till the 21st instance, right, the P1 process will basically get executed. Then for the P2 process, it will execute for 3 units. So that's why it is 24, and P2 process is executing after that. So this is how we are showing how the CPU is basically being utilized. Then we have the P3 process, which will take up 6 units of time. So this is 30 over here, sorry, for the P3 process. Okay, and the last one what we have over here is a P4 process which goes up to 32. Okay, so this is what a Gantt chart is. Gantt chart is basically a representation of how the CPU is being utilized and in what order. Okay, and here the burst time is basically, you remember, the amount of time for which you utilize the CPU. Okay, and since here this is how we do the representation in first come first serve kind of a situation. Okay, now if you have to calculate the average waiting time over here, right, you can just simply go ahead and check that this process waiting time is 0 because it came in the ready queue, arrival queue, the ready queue at 0, and then at the 0th instance also it got the allocation of the CPU. This process P2 had to wait for 21 seconds in order to, or 21 unit of time in order to get the allocation of the CPU. P3 started at 24. That means it had to wait for 24 seconds in order to get the allocation of the CPU. And P4 had to wait for 30 seconds to get the allocation of the CPU. So if I have to now calculate the average waiting time, it will simply be to add the waiting time for every process, which is 0 plus 21 plus 24 plus 30, divide by the total number of process, which is 4, and this is 18.5 milliseconds. So on an average, every process has to wait for approximately 18.5 millisecond before it could get the allocation of the CPU. And like we always say, we have to ensure that the waiting time is low, and because of which we can say that the scheduling algorithm becomes better. Okay, so that's how the overall idea works over here. Let me give you another example so that we can concretize on the concept that we just discussed. So we have process P0, P1, P2, P3. We have the arrival time, which is, let's say, different now. Then we have the burst time, that means the time it takes to execute. So this is 5, 3, 8 and 6. Okay, and now you basically have to see here what would be the Gantt chart for this. So at the 0th instance, there is only one process available, right, which is available for its execution. So we simply execute that process. So starting at this till this, we basically have this. Okay, now at P1, right, for process P1, as you can see at the 5th instance, right, the time is 5 right now, and so far all the processes have basically arrived. Okay, but which is the first one which arrived, right? So this is a ready queue. Think of it like a ready queue. At t is equal to 0, the queue looked like this, where only P0 process was there. But at t is equal to 5, okay, first the P1 process came, then the P2 process came, and the P3 process came after that, after a second only. Now the first one is P1, so P1 will be executed. So here P1 will take up the units, okay, and for how long? 3. So this is till 8, okay. Then you have the P2 process. P2 process is now the one getting executed next, and it has this 8 units. So it will take P2 till 16. Okay, and after that we have 6 for P3, and this is 22. Okay, so this is how the execution will basically happen. Now what will be the waiting time for each and every process? For this it was 0, for this was 5, for this was 8, and this was 16. Okay, that's the waiting time for each and every process before the CPU gets allocated to it. Okay, and what would be the average waiting time along with that? Right, it is 0 plus 5 plus 8 plus 16 by 4 over here. Okay, which will be 5.75. That means on an average, every process has to wait for 5.75 milliseconds. Okay, so this is what first come, first serve scheduling algorithm is. The processes which are coming first in the ready queue are the ones which are getting first executed as well. Okay? That is what the overall idea is. A few things to note over here regarding the first come, first serve scheduling is that obviously there are a few shortcomings or the disadvantage of using first come first serve. The easiest or the advantage is obviously that it's very easy to implement, right? It's very easy and it's very simplistic to implement a first come first serve. But the disadvantage is, first of all, that the waiting time is not optimal. Like, we have better algorithms which can do far less waiting time compared to first come first serve. Okay, so that is one point. Second point is that it is a non-preemptive scheduling algorithm, which means the priority does not matter. Process priority does not matter. It may be a case that a high priority process comes up, but it will still have to wait in the queue like any other process. Okay. So that is what the overall idea is about the disadvantages of, I would say, using the first come first serve algorithm. Okay. And I hope this is clear to everyone as well. First come first serve as an algorithm is very easy to implement, very easy to understand as well, right? It's just that it takes some knowledge from your end in order to fully comprehend and understand what the concept over here is. Okay. One more thing too important to remember and to understand with this concept of first come first serve is the importance and the discussion about convoy effect. Okay, what exactly is convoy effect? So the idea is that the first come first serve as an algorithm suffers from the convoy effect. Okay, that means if the first time or if the burst time of the first job is very high, right? What happens is, because the first process is very high, all the other processes have to wait a lot in order to get executed. See, don't you think our life would have been very simpler and the average waiting time would also have been very simpler if we could just implement this process P1 at the very end? Because it was taking a lot of time. Okay, and since it was taking a lot of time, the other processes had to wait a lot, although the burst time for those processes was considerably low, right? That is what the concept is of convoy effect. Okay, and first come first serve algorithms basically suffer from the convoy effect. Okay, where the burst time of the first algorithm is highest among all the processes that we have. Okay, so it's like a convoy is going, right, where there is a longer job followed by a lot of short jobs. Okay, imagine a real life. If a convoy is passing through the road, right, other persons gets blocked because of it, right, and they cannot pass until that big convoy has actually passed. Okay, so if the CPU gets the process of the highest burst time at the very front of the ready queue, then the processes of the lower burst time gets blocked, right, which means they never get the CPU until and unless the execution of that big, I would say, convoy or that big process is completed. Okay, and a very good example for that is what we saw on top of over here. Okay, where the waiting time because of this very big convoy made the overall execution for other processes after this considerably slow. Okay, so that is one another disadvantage of using first come first serve scheduling algorithm. Okay, and that disadvantage would be that because of a long job or a long process in the start, other processes in the queue have to wait a lot, which kind of affects the overall waiting time of the algorithm. So keep in mind and try to see if it is possible to have less waiting time. And if we, although we cannot control it because this is a non-preemptive scheduling algorithm, there is no concept of priority. So you will have to execute in the very way possible. Okay. And this concludes our discussion about first come, first serve scheduling algorithm. Okay. I hope this is clear to everyone. The best way usually to learn and have a better understanding about these concepts would be to try out on your own. You'll find a lot of examples and questions on the internet, right, where it will show you the process time, the given time, right, the arrival time and the burst time, and you just have to create a Gantt chart and calculate the average waiting time. Okay, so do try out more examples on top of that. I hope you are able to learn from this and understand how exactly the Gantt chart is prepared over here as well, right? And using this, you will be able to solve any example that comes up. Okay, remember that arrival time is very important. It may so happen that this process, let's say, is 6. Okay, now by the time at t equal to 5, this process is not as even in the queue, so you cannot execute this process. Okay, so keep practicing, keep moving ahead, and we will definitely meet in the next scheduling algorithm, which will be shortest job first scheduling. All right. Thank you so much for taking a look at this video, and I will definitely meet you in the next one. Bye.